Okay, in this video we're going to talk about the rules for exponents. Most of these you should know. Remember that when you're multiplying exponents with the same base, you simply add the exponent. So if we have y to the 4th times y to the 10th, we get y to the 4 plus 10, or y to the 14th. Same thing happens if we have an actual number instead of a variable. 3 squared times 3 to the 4th would equal 3 to the 6th. Of course, you could also simplify that and actually do 3 to the 6th power. So we can say the rule for a to the m times a to the m equals a to the m plus n. Okay, so what about if we are doing division? We'd say that y to the 10th over y to the 4th is the same as y to the 10 minus 4, or y to the 6th. Again, it also works when you have a number instead of a variable. 3 to the 6th minus 2, or 3 to the 4th. So we can say the rule for a to the m divided by a to the n is equal to a to the m minus n. Okay, we have some more rules. Okay, if we had y to the 4th divided by y to the 10th, we're still going to do y to the 4 minus 10, but this time we get y to the 6th. And of course, we cannot have any negative exponents, so we know that this time we're going to have to put it down, and we're going to get 1 over y to the 6th. Works here too. 3 to the 2 minus 6 gives you 3 to the negative 4th. So we get 1 over 3 to the 4th. So the rule here is if we have a to the negative nth power, we have to put that negative down. We don't want any unhappy negatives, unhappy exponents. 1 over a to the nth. Remember, if you have a negative on top, you put it down. If you have a negative on the bottom, you move it up. Okay? Rule number 4, power to a power. When you have a power to a power, you multiply those exponents. So y to the 3rd taken to the 4th power is the same as y to the 3 times 4, or y to the 12th power. Here, if you have a number taken to a power, you've got to distribute this and do 3 squared plus 6 to the 2nd power. So we're going to do 3 squared and then 6 times 2. So we would get 9 and then to the 12th. So the rule for a to the m times n, well, you're going to get a to the n and then to the 12th, or whoops, to the mn. Example 5, which kind of shows a breakdown of this. If we have 12 to the 5th times x to the 5, we could rewrite this as 12x, take the whole thing to the 5th power. In other words, I just did the reverse of this. So the rule is if we have a to the nth times b to the nth, we can say a, b to the nth power. Okay, so now, we've reviewed all your exponent rules that you should have learned long before now. So let's look at another one. Let's say that I had a to the nth. So if we have a to the nth, equals a to the m, then we know that n equals m. Okay, so looking up here again, I said that a to the n equals a to the m. This means that n equals m. So let's look at this example. I have 9 to the x minus 3 equals 9 to the 7th. So if I know that 9 to the x minus 3 equals 9 to the 7th, what else do I know? Well, I know that x minus 3 equals 7. So what did I do here? I eliminated my 9s. Why can I do that? Well, because the 9 is extraneous. I know that these are the same, so I can take it away because they're same bases. I have this left, and now I can solve to find x. By adding 3, I find out that x equals 10. And if I went back and looked, I see over here I have 9 to the 7th. If I put this in, 10 minus 3 is going to give me 7, and then I would have 9 to the 7th equaling 9 to the 7th. So I can do the same here. Remember, if you have same bases, you add your exponents. So up here, I could say, and this is the same as saying 5 to the x plus 2. I can say x plus 2 equals 7, same base here. X plus 2 equals 7. So now I know, whoops, that x equals 5. So I know that if I have the same base, then whatever the exponents are, I can set equal to each other, and I can solve to find any variable that there might be. Now you have some more examples in your notes. Please work through those, and we'll go over them in class tomorrow.